Welcome everybody to this Elastic meetup. Today we're doing part 3 of a series about data management with the Elastic Stack. I'm joined by our speaker, Muhammad, who's a fellow Elastician, as we call ourselves. My name's Mark. I work with the community team at Elastic. I have done a whole bunch of meetups in the past, and you may have seen me there or maybe on our forums. Just before we do start, I will remind people that this session is being recorded. We will have it available up on YouTube after the event. So if you don't catch it or you get pulled away, don't worry. We can share that with you later. So just really quickly, this is one user group of a couple of hundred that we have around the world. We do have very regional specific ones, so you are likely to have one in a city near you. If you head to our community event site, you can find a local user group, check it out. As we come out of COVID, we're hoping we're able to do more and more, get back to in-person events. In the meantime, we've been doing a lot of virtual ones like this, but do check out your local user groups. You can probably find some people that are close to you that you can chat about the Elastic Stack with. Here's a couple of QR codes and some links, some shortened links. Again, we'll have the slides will be available later with the video, so don't be too worried. We do have a community Slack instance for any real-time questions that you have. This talk and all the meetup talks end up on YouTube as well, so definitely check that out. There is a quick link down there in the bottom left to this user group, which is a virtual one, so this is an encompassing one across different time zones. Feel free to join that too. We do promote other events in other time zones into that one. And finally, we have our forums where you can hop on and chat to fellow community members and Elastic engineers and ask us any technical questions. We do have a community contributor program, which is pretty cool. This is ongoing. We're into our second year now. So this is a way for us to recognize people that are contributing to the Elastic community and the ecosystem. So this can be presenting at meetups or at a conference. It can be code-based. It can be answering questions on Stack Overflow or writing content. We take all of these in, we score them and we rank them, and then we award prizes based on the different ranks. If you are interested in more about this, head to the URL there and you can find further information. It's pretty awesome, actually. We've seen some amazing things coming out from people that are already creating this content and using this to be recognized. We're hiring, as usual. Elastic is growing pretty aggressively. Here's just a few different jobs that we're looking to fill. In ANZ specifically, we are actually looking to hire a community advocate in India. If you're interested, please reach out to us about this. And as part of this meetup, you get a special Elasticsearch service trial. So this is an extended trial beyond the 2 weeks. And if you head to this link, you can sign up and check out all of the functionality that Mohammed's going to be talking about and a whole bunch more. So, Mohammed, I will just stop sharing. And then I will hand over to my colleague, Muhammad, who is still at the beach, and it looks fantastic there today, mate. So I'll leave it with you. Thanks, Muhammad. If you haven't already seen the other two, check out our YouTube channel, the other 2 parts of this session. The first part was around ILM, which is a way to automate index management. So this is for people that may have been using the Elastic Stack for a while. We did have Curator, which would do some of that. ILM is an integrated way of doing it now, which is really fantastic. Part 2 was data streams, which is a way to abstract away time-based indices. And it integrates ILM, index lifecycle management, Snapshot lifecycle management, or SLM as well, and bundle those into just an easy to use abstraction, which is really awesome. The last one today that we're going to be talking about when Mohammed jumps back on is Searchable Snapshots, which is relatively new for us, but it's a way to literally take a snapshot, a backup of your Elasticsearch indices, put it into something, some sort of offline storage, and still search them, which is really, really powerful. It's great for long-term data storage. Rajesh, preferred way of using Elastic Stack. We definitely recommend using the Elastic Cloud service, which is managed and built by us. That is definitely the way to go. It gives you access to pretty much all the features. There's a few things that aren't available just due to security concerns, and I can answer some of those if you're interested. But that's probably the most common way we're seeing these days. The adoption for Elastic Cloud is pretty phenomenal. You can definitely still run it on-prem, so within your own data center. You can also run it on any other cloud server that or cloud hoster that may provide instances. And yes, you can use Active Directory authentication for Elasticsearch as well, and Kibana. All right, Mohammed's back. I'm going to just put the questions on hold. We'll revisit them at the end. Mohammed, I will hand over to you. Thanks, mate.
Mark, thank you for holding the fort. All right, so hello and welcome everyone. My name is Mohammed, and I'm an education and consulting architect based in Melbourne, Australia. I've been part of Elastic for around 3 years now, more than 2.5 years, so around 3 years now. And I basically deliver consulting and trainings around the Asia Pacific region, starting from including India and to New Zealand, if you call the whole vertical of the Pacific, including Australia and everything in between. So we are doing this 3-part series, and today's the last part of this series on data management with Elastic. For those of you who weren't part, who didn't attend the last 2 sessions, in the first session we talked about dealing with time series data and dealing with the growth of time series data using index lifecycle management. And then in the second topic, we then started talking about data streams to basically streamline your data ingestion and data access issues when dealing with data at large scale. And now in this third part, we're going to talk about searchable snapshots, which is kind of 2 things: snapshots and then making them searchable. So what are snapshots? How do we make them searchable? How do they help us in data management? So all of these issues we're going to talk about today. So let's get started with that then. Okay, so early on, we defined data in two kind of streams. There is static or relatively static data, and then there is time series data. Static data doesn't grow with time. It's because it's static or relatively static. Whereas time series data, it grows with time and grows very, very quickly. Other couple of properties of time series data that we are seeing here are it is sometimes event oriented and it never gets updated. An event is something that happens in a time, in a given moment in time, such as, for example, log, a log event, for example, if your application is being used by customers, then at any given point in time, there could be a number of things going on behind the scenes. Your web server is generating logs, your application is generating logs. If there are any errors or debugs happening, those are being logged as well. So all of these are kind of examples of events. And they, once they get generated, they never get updated. So this is one of those very core examples. The other thing is it grows quickly, but then it loses value over time as well. So that's another property, right? When we have this huge spikes in data that we are ingesting into Elasticsearch, how do we deal with them? That we kind of looked at in the last two in this series, in the last 2 episodes. So we use the data tiering. So we use data tiers, and data tiers are made up of the data nodes. So in our Elasticsearch cluster, we have a set of nodes that tagged as data nodes, and within those data nodes, then we further do some classification, categorization of the nodes as hot nodes and the warm nodes and the cold nodes and the frozen nodes. And this classification or categorization of nodes is basically to deal with deal with the growth of data with respect to time, And this tiering then reflects on the value of data over time. So the most valuable data is in the hot tier. The slightly less valuable data is in the warm tier, slightly more or less in the cold tier, and then in the frozen tier. And then what do we want to do after frozen tier? That's what we are gonna focus on today's talk, right? So up until cold and frozen tier, we looked at in ILM in the very first episode of this series of talks, and then we talked about data ingestion using data streams. So let's get to it. So that's issue number one. The second issue is you are ingesting data, loads of data into Elasticsearch clusters, and at any given point in time, your cluster could have petabytes of data in it. What happens if your cluster goes down? Something happens to the nodes in the cluster, or all of your cluster, all the nodes of the cluster, they just poof, go. There is a catastrophic failure. What happens then? So that's a disaster, right? So how do you recover from that disaster, right? So these are then two issues. One is dealing with the growth of data. Once data reaches to a certain point, then what do we do with it? And the second is data is sitting in the Elasticsearch cluster, and if something happened to the cluster, what do we do with it, right? We talked about shards, a couple of types of shards, primary shards and replica shards that we have, which are indexes composed of, basically, right? So primary shards of an index are the primary shards where the data comes first, and then the replica shards are the copies of the primaries, right? Why do we have those replica shards? They are to support the high availability within the cluster, right? If a node goes down, for example, then we'll have, and it has a primary copy of the data, then a replica would be on some other node, and we can just promote that replica. Elasticsearch will automatically promote that replica to become primary, and that way we will ensure that the failure does not happen. But what happens? This disaster then refers to when your whole cluster goes down, right? You lose your primaries, you lose your replicas. Now it's time to recover, right? That's a disaster. How do you recover from that? And the way to recover from that is taking a backup of your data and your cluster state, right? That is called taking a snapshot in Elasticsearch terminology, right? So how do we take these snapshots? We're going to talk about them. So then, coming back to the first thing that I talked about, dealing with the growth of data. How do we deal with that then? So we have implemented ILM, hot, warm, cold architecture using ILM. So our data is, most recent data is in the hot tier, then in the warm tier, the slightly less old data, then slightly less old data in the cold tier, and then in the frozen tier, we have the oldest data. From that point onwards, we have a couple of options. We can either delete the data to make room for more data in our cluster, right? Because our cluster is going to have a set capacity, right? We just cannot keep adding on more and more and more disk space, right? We're going to have to put a stop somewhere. That's one. And then the second is maybe we can take it off the cluster, and then whenever we need it, we can bring it back, right? So as to speak, we can archive that data instead of deleting it, and then we can restore that archive later on when we need it. And we never know when do we need it. We might want to keep that for many reasons in the archive, the data in the archive. We might want to keep that in the archival for many reasons. One of those reasons is due to company policies. It could be governmental policies that are asking us to keep that data with us. So it could be due to multiple things. But then that's a very, very good option to keep that data handy in the archives, and whenever we need it, we can then use it. So then putting the data into archives is in Elastic terminology, like I said before, it's called snapshotting. Taking backups or putting the data into archives is called snapshotting. So we're going to talk about these snapshots. And while we are taking snapshots of data in the cold and frozen tier, we can keep that data searchable as well. So when the traditional concept is you take the backup of the data, you archive it, and then that data is off of the cluster, right? If you want to search that, if you want to make a search on that, you're going to have to bring that data in Elasticsearch, right? Restore that, and then you can search on it, right? But with searchable snapshots, you don't have to do that. You can do both of these things, have the data in the archive and have it searchable as well, right? That's a big win, right? You get to like have both of the good of both of these worlds, right? The data is in archive, it's still searchable. That is called searchable snapshots. How do we deal with that? First, we're going to tackle how to take snapshots, and then we're going to talk about how to make them searchable, right? So let's let's go forward and let's talk about snapshots. So then snapshots let us back up our data, right? The snapshot and restore process that we have within Elasticsearch, that the APIs and the Kibana UI, the Kibana UI layer that we have that lets us create and manage the snapshots, the backups, right? So this process of taking snapshots or backups really starts from first registering a repository. This is the place where the data is gonna be archived in, right? What can go into this repository? Your data can go into this repository, and your cluster state can go into this repository. Your cluster state comprises of, the indexes, the metadata, the detail of the shards, the details of the nodes, your ILM policies, your index templates, and so on and so forth. All of these kind of things, they are into your cluster state. And really backing up your cluster state is important from the data, from disaster recovery point of view. If you are restoring your data from, if you are in a disaster recovery scenario and you're restoring from a snapshot, and you have the cluster state saved in the archive, then your cluster is gonna come back to life a lot more quicker, right? Because then you do not have to bootstrap your cluster. You already have the cluster state saved, and the cluster is gonna restore from that state straight, right? You're not gonna have to wait a lot. Now talking about repositories themselves, they can be, these repositories can be on many, can be on different places, right? You can have them on the local shared file system, or you can have them in the cloud, right? So the snapshot process then is going to take the current state of your cluster and the data, and then it's going to put that into that repository. The repository then can be, like I told you, can be on many different places. It could be on the shared file system, right? In which case you're going to have to define the path to that shared file system using the path.repo property, and that path.repo property, you're gonna give the path to the data directory, to this, or to the shared file system, to this path.repo property, and this property gets defined in the elasticsearch.yaml file of each node, right? If you are storing it in the cloud, then you have options. You can go with AWS S3 storage. You can go with Microsoft Azure, Google Cloud. You can store snapshots in Hadoop clusters as well. And then if you go with any of these options, you're going to have to do one extra step, which is to install the relevant plugins to be used with that particular cloud provider. So these plugins are supplied to you inside the plugins folder of your Elasticsearch distribution, if you're doing this. Otherwise, if you are using Elasticsearch in the cloud service, then depending upon the cloud, depending upon where you have spun up your cloud, like for example in AWS or Microsoft Azure or Google Cloud, you're going to have by default a repository registered in that cloud service for you, right, to get things started. So if you have spun up your cluster yourself and you want to use a shared file system to store your snapshots, then the first step is registering a repository. And really, this can be done really conveniently using Kibana management interface. So then you got to go to your open up your burger menu on the left-hand side, go to the stack management, and under once you're in stack management on the left-hand side, you're going to see snapshot and restores, and that's where you're going to find this whole user interface that lets you create and manage repositories and snapshots and snapshot lifecycle management policies. So the first step then is going to set up your repository, and it's going to take the name and the type. And the next thing it's going to ask is where, if you have the path.repo already set, then it's gonna automatically figure that out, because you would have configured that already in Elasticsearch.yaml file, and that would be available to Elasticsearch through those system properties. So once you have the repository configured, now you're ready to take the snapshot, right? I'm showing here you the API way of doing things, because the UI way of doing things is super easy. I've shown you the first step to register a repository. Everything else is kind of pretty intuitive through the UI. So that, but if you want to do it through API, for example, you wanted to automate it, you wanted to make this part of your other configuration management tools pipelines, such as Ansible, for example, then you could do it in this way as well, right? So you get to see how things get done through APIs. So you send the request for taking backups, for taking snapshots to the _snapshot endpoint, right? The snapshots are point-in-time copy of your data, right? What do we mean by point-in-time? Point-in-time means if we have started the snapshotting process, the time at which the snapshotting process started, that is going to any data that is available at that point in time is only going to be part of that snapshot, right? Anything, if you are doing the data ingestion, live data ingestion if that is happening, then anything that happens, any data that gets ingested after that point in time, snapshot has started, that data will not be part of the point in time copy of that snapshot. Then the next thing is snapshots are incremental in nature, right? So that means you can take frequent snapshots. So I told you about the point in time nature. If you are ingesting data and you have some data that is not part of the previous copy of the backup that you have taken, then you can run the next backup, and you're going to be ensured that the data that's been part of the previous backup, it's not going to be touched again. The new data that the cluster has indexed, that's going to be part of the new copy of the backup, right? So that way you have kind of your backup sitting in chunks, incremental chunks, right? Storing diffs, if you can see it in that sense. The second thing is you can choose to back up what you want, right? You can back up everything, or you can back up what you want, right? If you do not give anything, any parameters, any payload to this put request that is shown in this example, then it's going to take the backup of everything that's in your cluster, like all the indexes, right? But if you just want a certain set of indexes, then you can use an indices property in the payload to tell Elasticsearch and the snapshots restore API which indexes do you want to be archived, put in snapshot. So here in this example, we say any indexes that start with logs hyphen, that's a prefix that we use. And then there are a couple of other properties: ignore unavailable and include global state. So ignore unavailable is set to true. That is gonna skip any indexes that are not available. So for example, the indexes that are closed for operations, they are kind of unavailable. If the ignore unavailable flag is true, it is not set to true, the snapshotting API is going to try to back up that index as well, and it's going to fail, right? It's going to fail because that index is not available. Only available indexes are backed up. And that's why we kind of say ignore unavailable to true so that our snapshotting process doesn't fail there, right? And then the third property is include global state is true. If we want to take the backup, or if you want to put the global state of our cluster, or cluster state as you call it, in the snapshot, then we can set the include global state to true. And it's really recommended to put that to snapshot that, to put the global state in the snapshot as well, so that if you are in a disaster recovery scenario, you can quickly restore your cluster into operational state without spending too much time into bootstrapping and then and having your cluster reach to that state after spending some time. So once you do this, you execute this request, your repository has been the repository that you have registered, the snapshots is going to be created and put into that repository. The put request you can see goes to the _snapshot endpoint, and then you get your name of the repository, my_repo, and then the unique name for your snapshot. Now you can keep taking these snapshots, right? It's expected that you're running a busy cluster, right? And it's not ideal to keep taking those snapshots manually, right? So you would ideally want to automate that process. Back in the days, you would automate that using scripts outside of Elasticsearch, but now Elasticsearch has the automation built in. So it's called Snapshot Lifecycle Management Policies, and they are part of, again, you can create them as part of Kibana Management UI. So this snapshot lifecycle management policy then defines how frequent you want to take those snapshots, how many snapshots you want to keep in the repository, and basically all those details. So we're going to take a look at how that policy looks like. If you want to use the SLM API, then it's available at _SLM endpoint as well. At any given point in time, if you want to restore from your snapshot repository, then you gotta use the _restore endpoint, and you gotta invoke that endpoint on your snapshot that you're wishing to restore, right? So you give a post request, you send a post request to the _snapshot endpoint, then you plug in your repository name, and then you plug in your snapshot ID, and then you say _restore, and that will restore everything in that snapshot, right? You can also do the restoration using the Kibana UI, right? So that's again through the Kibana management interface, and that's basically in a nutshell what the snapshot and restore process, and it's really very easy. Now extending it for our hot, warm, cold, frozen architecture, right? So we have time series data. It's growing. Our cluster is like getting fatter and fatter, right? So what do? We gotta pull that data off of the cluster and put it into archives. That's our snapshots, right? But if we still need the data, it is still useful, right? Then we want to restore it very often, right? And that involves effort. It requires manual effort of restoring. Then it requires you to basically do it manually, right? Restoring it manually. That's one. You got to spend some time doing it every time you do it manually, right? It takes time to restore, and then once you are done, you got to delete it so that it's not anymore in the cluster, and then when you need it, you got to pull it out of the archive again. So that manual process, and then the fact that it's going to spend some time getting restored every time, that is painful for a busy cluster, for a busy business operation. That's painful. So why not take the snapshot and keep it searchable, right? Take the snapshot, pull the data off of the cluster, and still make it and still have it searchable. So that is what the searchable snapshot is. The idea is that when you are in the cold or the frozen phases of your index lifecycle management, you can make your data searchable, and you can put them in the snapshot repository, right? So the benefit is then the replica copy of the data is going to get moved into the snapshot archive, so you won't need any replicas. The primary shard is still going to be mounted for searching in the cluster. So that way, that is how the internal mechanics work, right? So you do not need replica copy, right? You do not need replica shards because your replica is sitting in the snapshot archival, right? And you have the primary shards available, and those are searchable then, right? And they are mounted. And once you don't need them, what your search need is finished, you can delete those mount points. You can delete that data from the cluster, and it's still available in the archival. So how do we do this then? The idea here is that the backup that you have taken, the snapshot that you've taken, that snapshot, a copy of that snapshot is going to be mounted within the cluster as an index, as a normal index that you would normally have, but it's going to be a temporary index in nature, right? It's going to be mounted locally, meaning only the primary shards are going to be present. The replica shards are not going to be mounted, right? Replica shards, we don't need them in this instance, and the replica is really sitting in the archival. So the index is going to go on to the data nodes, right? So index is going to go on to the data nodes of the cluster. That's where it's going to get mounted, right? And after it's done, right, your index is searchable. Your index is searchable like any other index and like any other search request. And just to show you where do you set it up in the cold and frozen phases, as an example, if you're in the cold phase, you gotta just check or enable the create searchable snapshot flag, and then provide the address of your snapshot repository, right? That's it. Once you are done this, your data is automatically going to be archived into this snapshot repository, and a copy of data is going to be automatically mounted onto your data nodes for searching. For searching. So that way, you kind of have increased the data density on your cluster because replica copies have moved into the archival, and you have your searches available live. You do not have to spend time restoring the archives from your snapshot. So that way you kind of have resolved both of your issues. And really, the third issue that we talked about, or the second bigger issue of disaster recovery, that gets solved as well, because you have your data sitting in the snapshot repository as archived data. And at any point in time, if your cluster is in a disaster state or goes awry, then you can just simply restore it. All right. So if you want to mount your snapshots yourself, right, manually, then you can just simply use the _mount endpoint, right? And the way to do it is you send your post request to _snapshot endpoint, plug in the name of your repository, plug in the name of your snapshot, and invoke the _mount endpoint. And then in the body of the request, you can specify some more configurations. For example, you can specify the index name from that snapshot that you want to restore. At any given point in time, a snapshot can have many indexes in it, right? So if you want to just restore one particular index, you can just name it, right? And then when you are restoring it, you can provide a new name for the index as well, so that you can identify it more easily within your indexes that are present on the cluster. So you can use the renamed index property. You can at that point in time have the option, if you want, to allocate number of replicas by using the index settings property, and then defining the index number of replicas. Now, generally, you wouldn't need that because you have one copy sitting in the archival. But then again, if your use case demands that you need this, you can configure it, right? And then you can specify the ignored index settings as well. So the default index refresh interval setting is going to get ignored in this instance. Okay, so now that we have restored our index, how do we search it? The search is just like you search your other indexes. The search request goes to your _search endpoint. So the name of, the way you formulate that request is, it's a GET request. You plug in the name of your index, which is logs mounted, and then you send this request to _search endpoint, and then in the body of the request you specify the query that you want to execute. Once the need to search on this data, this index finished, you can simply invoke the delete index command, and you can say delete logs mounted to delete it if you want to. Now, one last thing, you can, and we have seen this already in one of the previous slides, that you can add this searchable snapshot functionality feature to ILMs, right? And ILM, as Marcus has pointed out in the chat as well, I didn't look at it at that time, but I can look at it now. Index lifecycle management, that it stands for. So you create your ILM policies, and within those policies, then you can define this searchable snapshot to be part of that ILM policy. And once you have this ILM policy defined, remember there is a delete phase in the ILM policy as well, right? If you have the delete phase active, right, it's gonna delete the searchable snapshot by default. So you want to turn that off. You want to turn the delete searchable snapshot off. So just turn that flag off, right? So that will then keep the searchable snapshot in the repository. The delete phase is not gonna delete it. And since we talked about the data streams last time as well, so if your ILM policy is applicable to your data streams, the searchable snapshot is going to be included in your searches anyway, right? Because your data streams are kind of abstracting all those details, so it's going to be included in your data streams anyway, those searches. And then to just turn this off to kind of and towards the end of this talk, I'll just point to some benefits of using searchable snapshots. It's really good for managing huge amounts of data, right? If you are talking about big data, if you are talking about dealing with large amounts of historical data, time series data, even relatively static, huge volumes of data, it is perfect, right? You get to save on costs. The amount of data that sits on your cluster, it's live data. It's sitting in disks, right? It's available. It's searchable. It's available, but it's costing you. You got to keep multiple copies of the data in your cluster to support the high availability scenarios, right? Requirements. But if you put a copy of the data in your less costly storage, right, which is your archival storage, then you save on costs. That's a big saving. And then most of the time you're going to be putting that into your object stores in the public clouds. So that way you kind of get virtually unlimited space as well. You're just taking it off of your cluster, increasing the data density of your cluster as well, right? Making room for more data that can be stored. You don't need any replicas, right? You don't need any replicas in this instance because replica is a copy for high availability use cases, right? Their requirements, high availability requirements. So if you have the snapshot taken and it's searchable as well, you already have a copy of the data sitting in the archive, right? You don't need a replica because you can just restore from your snapshot. The storage space I told you about, that it's dramatically going to reduce the storage space requirement as well. The search speed is slower, right? Search speed is slower, but but then you have other ways to manage that search speed requirements as well. So force merging your segments has been seen in the wild to increase the searching speeds. So as an example, I was reading a use case, and the search was happening on 1 petabyte of data stored in searchable snapshots, and it took 26 minutes to perform the normal search. And then they did the force merge, right? They did the force merge, and after doing the forced merge, that same search executed in 2 minutes. So you can see the scale. You have the ways to optimize that. Force merging is just one thing, but then optimizing the search queries themselves solves a lot of problems as well, right? All right, so that is the end of my talk, and then I'm just gonna see if there are any questions.
Hey, Mohammed, thank you for that session. It was informative. Is there any way to provide security to Elasticstack? Any Active Directory options or anything?
Yes. So, like Mark answered this question previously as well, there is the option Elastic Security module. You can benefit from enabling the Elastic Security using the Elastic Security features, and security works at different levels. You talk about the Active Directory support. So Active Directory can be integrated with Elasticsearch. You can specify the Active Directory settings configurations into the Elasticsearch.yaml file, and that way you're going to have your Active Directory integration happening, and you can basically implement that. Yeah, it has in Elasticsearch. Yes, supported by Elasticsearch. Yes.
Okay. Is it available in the free version, or does it need any kind of license?
Mark, do you know that if there is?
Yeah.
What kind of license?
The active the AD auth is a non-free license for that one. It's not something that we have on cloud either, because the concern that we have is getting people to open up their AD instances to allow Elasticsearch to authenticate to them sort of seems a bit of a backward step in terms of security. The core or the native basic authentication and access control is free in if you download the stack. It's also in our cloud deployments. You can use SAML, OpenID, Connect, and Kerberos on cloud as well, if that's if any of those are of use for you. Look, thanks everyone for joining this afternoon or this evening, wherever you are. Mohammed, thank you for wrapping this 3-part series up. It's been really fantastic. If you would like to learn more about ILM or data streams and you're watching this one, check out the first 2 parts of this, and we will hopefully see you again for another meetup. Have a good rest of the day, the afternoon, or the evening, wherever you are, and we'll catch you later. Thanks a lot. See you, everyone.